Hi, I'm Luke Kane. Welcome back to Algebra 2. Today we're going to talk about systems of equations, and specifically how do we solve systems of equations graphically. You recall from the last video that we had a problem at Oktoberfest. We didn't speak the language, we couldn't read the signs, we didn't know what the beer costs. So we made some observations, and we wrote down our observations as a word problem. And this is the word problem. If you want to learn more about Oktoberfest, you might want to check out this official webpage for details. In any case, we then took the word problem and we translated it into a system of equations. In this case, we ended up with two equations, 6x plus 4y equals 48, and 2x plus 4y equals 32. So we have two equations and we have two unknowns, x and y. So now what we're going to try and do in this video is we're going to try and take these linear equations and we're going to plot them. And we're going to use the plot to determine the solution. So let's examine these two equations a little more closely. Here is equation 1 and equation 2. Both of these equations have a form that should be familiar to you. The form I'm referring to is ax plus by equals c. This is the standard form of a linear equation. So let's look at equation number 1 and compare it to our standard form. 6x plus 4y equals 48. And right away it becomes evident that a equals 6, b equals 4, c equals 48. Therefore, our system of equations is linear. That is, the graph of each equation should be a line. So let's check that out and see if it's true. Of course it's true. We know it's true. So let's plot them. 6x plus 4y equals 48. That's our first equation. 6x plus 4y equals 48. And that's our first equation. All right. Euclid told us 2.5 millennia ago that a line is defined by 2 points. So to plot this line, all we need to do is find 2 points. And let's find the two easiest points we can. And I think the two easiest points are the y-intercept and the x-intercept. Let's find the y-intercept first. How do we find the y-intercept? Well, we set x equal to 0, and we solve for y. So we have 6 times 0 plus 4y equals 48. 0 times 6, 0 times anything for that matter, is 0. So when we multiply anything by 0, 0 becomes the great destroyer. And in this case, it kills that term, and we're left with 4y equals 48. Divide both sides by 4. That becomes 1. 1 times y is y. Divide 48 by 4, and we get 12. So now we have y equals 12. And we've now defined 1 point. 1 point for our equation. It's going to have the x coordinate is going to be 0, and the y coordinate is going to be 12. So let's plot that point. 0, 12. Well, 0 on the x, in the x direction is going to be 0, so we stay at the origin, and we go up 12. 5, 10, 11, 12, right about here. So that's the point 0, 12. All right, all we need is one more point, and we can plot our first line. Well, the other easy point is the x-intercept. And it's easy because intercept. There we go. If I could spell, I'd be deadly. And it uses the same KISS principle. We're going to keep it simple, stupid, by using the great destroyer. at least the great destroyer in multiplication, and that's y equals 0. So we're going to set y equal to 0, and that's going to make 6x plus 4 times 0 equals 48. That's going to cancel. And that's going to leave us with 6x equals 48. Divide both sides by 6. That cancels. 6 goes into 48 8 times. So we have x equals 8. So now we have defined another point. We set y equals 0, and we have x equal to 8. So that gives us the point 8, 0. Let's plot that point. 8, 0. All right, 8 is in the x direction, in the positive x direction, so that's 5, 6, 7, 8. 8, 0. It's always good to label the points. Oh, and of course that forms a line, so let's connect the dots as best we can. Doing this freehand. Okay, and that's our first line for equation 1. So we call it L1. All right, realizing that this is for equation 1. All right, let's do our second, and let's speed up the process a little. Bing. Here's our second. Here's our second equation. You can pause the video here just if you want to check my math. The y-intercept for the second equation is going to be 0, 8, and the x-intercept for the second equation is going to be 16, 0. So let's plot them. 0, 8. All right, so we're at 0 in the x direction. We're going to go up 8. That's 5, 6, 7, 8. So that's 0 and 8. And our other point was 16, 0. 16, 0. So we go over 5, 10, 15, 16. So that's 16, 0. Oops, running out of room. And we connect the two dots again for line 2. So that's line 2, which corresponds to equation 2. So our solution is staring us right in the face. The solution is the point that both lines have in common. Right? So let's find out what that point is. So we count over from the x-axis. 1, 2, 3, and oh, I don't know. Let's say that's 3.5. It's hard to tell. And we count up. 1, 2, 3, 4, 5, 6. Oh, I don't know. Looks like 6.5. Oh, but wait a minute. Wait a minute. We did this before. We did this
Error.
in the last video. And when we did this in the last video,
Error.
that was not our solution. Our solution
Error.
was 4, 6. Well, this is close, but close is not correct. This is an error. Why is it an error? Well, it's because I drew these lines by freehand. And, of course, my lines are not exactly straight. So let's do this process again. And only this time, let's ensure that the lines are straight by having a computer plot the lines for us. So let's use a graphing application to plot our lines for us. I've taken the liberty of taking the first equation in our system of equations, and I've reproduced it here in blue. And I took the second equation in our system of linear equations, and I've reproduced it here in red. And from the calculations we just did, here is our x-intercept and our y-intercept, and I can plot those. And they show up on our graph as points A and B. And now I can connect the dots. Oh, yes! ladies and gentlemen, boys and girls, look at how nice and straight that line is. It is significantly, infinitely straighter than I was able to do by hand. So let's plot the second equation. And again, all I need is 2 points. I have the 2 intercepts here, the x-intercept and the y-intercept. So let me plot the 2 lines. They show up on our grid as points C and D. And I connect the points, and I get a red line. Now, the red line corresponds to my red equation. The blue line corresponds to my blue equation. There is only one point that is on both lines, both the red and the blue line, and this is the solution. And it's important to realize this is a unique solution. This is the only solution. This is the only point which is both on the red line, on the red line and on the blue line. Therefore, it is the only solution. Whatever x and y is at this point, it is the only x and y that will satisfy both this equation and this equation. So let's see if we can find it. All right, well, what we got to do is we got to find x and y. Might be easy to do this if we show the grid. So here's our grid. So first we want to find the x coordinate. So we count over 1, 2, 3, 4. So x equals 4. And then we count up 1, 2, 3, 4, 5, 6. X equals 6. So our solution is 4, 6. Yes! That's what we were expecting. In our last video, we got 4, 6 by guess and check, and we know this is the solution. Now we know that this is the only solution. So this is the solution. And it is the unique solution. There is no other solution to this system of linear equations. So what did we learn today? Well, we looked at a system of 2 by 2 equations, and we found that we could fit each of those equations to the standard form of a linear equation. Namely, they both look like the form ax plus by equals c. That meant that both equations are linear, or in simpler language, both equations could be graphed as a line. And since they could be graphed as a line, there's one point where the 2 lines are going to intersect. That one point represents the solution, because it's the only point on the 2 lines which will satisfy both equations. And the key insight from looking at the geometry of this system of equations is the fact that in this case, where the 2 lines intersect, there is in fact only one solution. So the solution is unique. So in our example, we had a solution 4, 6. That's the point 4, 6 was the only point on the blue line and the red line which was true for both of them. Now, we also saw limitations, unfortunately, in graphing systems of equations. We saw when I tried to graph a system of equations by hand, I got the wrong answer. It was close, but it was still wrong. And, of course, we were able to fix that, but it brings up the issue that although your textbook problems are going to tend to have nice, neat integer solutions, in the real world, not so neat. Usually the solutions are decimals. And one of the things about graph paper is it's very hard to read decimals on graph paper. So, in a sense, from a practical perspective, 2 by 2 systems of equations can be graphed, and we can find a solution. But basically the solution is an approximation. It may be a very good approximation, and from time to time we might get lucky and get an exact solution, but the chances are pretty slim. And of course, if we think more about this graphing, what does it mean to graph a system of equations where we have 3 dimensions, as we have in this system of 3 by 3 equations? How do we graph something in 3 dimensions? Or even stranger, how do we graph something in 4 dimensions, 5 dimensions? Till next time, thank you for watching. Bye for now.